the exercises that we have. And so if we go over to our Wolfram class and we say, okay, let's take a look, and we go inside the assignment and we look at the instructions and we say this Wolfram document. So let's try it. Okay, so remember we want to make our own copy. Alright, so well, that didn't work out too well. Let's see if it works to say Tom. Sterling, so let's see if that works. So see, maybe it remembers. Oh, thank goodness. Okay, so make a copy. Alright, so we'll change the name and we'll call it TK and we'll check it. Okay, so now it says, so please try and do these on your own, but I want to have a randomness of 3, of 5, and so we say data pairs. So in our table, if we look at what we did, we multiplied by 2. So we say, okay, we can change that. And so instead of multiplying by 2, we're going to do 3 times the index. So when you put in a 1, we're going to do 3. And then instead of plus or minus 2, we're going to do plus or minus 5. Okay. And let's do that for 40 of them. Okay, so we say, all right, let's try that. Okay, so we get this, right? So we do it for the first 1 through 40. Let's see, so for 40, we got 40 times 3, 120, plus a little bit, right? So, and then let's try for 2, we got plus. For 3, we got plus. For 4, we got plus. For 5 times 3, 15, we got a minus, right? So as you look through, you see how things have changed. So if we say, okay, let's look at our data pairs, and we evaluate, say, okay, we got a jagged line, which shows that there's some of that randomness by having plus or minus 5. Right, and it's a little bit steeper line. Okay, so now we say, okay, let's generate a line, and so say, okay, so take a look at that, and the line. Okay, so the line is because of the jaggedness, it doesn't quite go to the origin. It's actually it's a little bit south. So, okay, we'll say that. All right, let's try and plot this. Okay, so we plot it, and we say, well, it's pretty close to the line of fit. All right, now we want to do the same thing, but have a y-intercept of 15. Okay. So we have a y-intercept of 15. So we're going to do our data pair with intercept, and we're going to copy the table command. Okay. Copy the table command, and we say, okay, table, and we want the intercept to be 15. So we say, okay, start off with 15 and then do 2 times the number, and let's do the randomness. So we're going to do a big random, so we'll do 15 as our random below, and let's do 15 below and just 5 above, and let's see what we get there. Okay, so we look at that and we say, okay, so there's our data. Okay, and we'll just try our commands. So we'll try, all right, let's do a list plot of those and see what that looks like. So we do list plot, but we're going to do data pairs with intercept. Okay, so pretty jagged there, and you can see where the slope is going. All right, so what else do we want to do? Well, we want to calculate our line of best fit. Okay, so we say, okay, we'll calculate a line of best fit. We put that in. Okay, but we want to do data pairs with intercept, so we copy that. So we don't want to do data pairs, we want to do data pairs with intercept. So calculate the line. Okay, so now our line, and you look at the line, has a slope close to 10. Why not exactly on 10? Right, so when you do real data, it's going to try and do the line, and maybe, remember we had a little bit more variance, minus 15 plus 5. Okay, and then finally, we want to do our show. We're going to do the exact same thing, but Okay. Again, it's going to be data pairs with intercept. Okay. All right, and we do that. So we do that. Okay, so now when I say let's do the whole thing over again, and you can just go and copy what we had. So we're going to do data pairs with intercept, and we say, all right, we're going to try it again. But this time we'll do it. So let's do it with even bigger variance. Let's do so with variance of 25 and with variance of 15 up above. So say, okay, let's do that. And we got that. So let's try the same thing with the line. So let's calculate the line. Okay, so I'm just going up and copying that. So you don't have to do anything different with this. Say, okay, I gotta copy that line. Okay. And so now you see, well, it has a strange, because of the randomness, you got this equation 4.3 as the intercept. Well, what happens if you just do it again? So we do it again, okay, and so we get a different randomness involved, and we say, well, what do we get this time? And now we get 8, right? So there's a certain randomness every time you do it. So we got line of best fit, and now let's just plot that. So we're going to show our plot. And so say, what does it look like? So short plot, and we shift enter, and we get this. So the data is all scattered about, but you see, you can still draw a line. There's still a general tendency, so there's not complete randomness to it. So it tends, as your value gets bigger, your x gets bigger, your y tends to get bigger as well.